Right, so Amy, I have particular pleasure in introducing Amy because Amy is a current MSc student with me in green building at the Centre for Alternative Technology. But in her other life, she's also a parent. She homeschools her kids. She is an energy advisor for Cumbria Action for Sustainability. And her unique take on this, what her talk's about, is how there's a way of doing assessments that don't just consider the energy or the materials, but they really consider everything, particularly the locality and the people, because the people are the ones who inhabit the building. So she's done a lot of kind of environmental accounting, looking at how to create the lowest environmental impact, but also the highest social and cultural value with her energy saving retrofits. So Amy started working with lime originally and has slowly moved, as we love to hear, into using local earth as a binder. So without further ado, I'd like to introduce Amy, who's going to lead us through her experience with environmental decision-making journey with earth.
Great. Hello. Just bear with me a minute and I'll try and fire up my PowerPoint presentation. Have you got it?
Can't see it yet.
You don't see it. What have I done wrong? That's not the best start, is it? Let's try again.
It's okay. We can all admire your tree in the background.
This is my lovely daughter's bedroom. Ah, that's what I've done wrong. There we go. Is it sharing now?
Yes.
Yes.
Great. Right, so I'm off, and here's to Amy.
Lovely, great. So this is a talk about our family's materials choices journey since buying a 17th century farmhouse in North Cumbria about 5 years ago. It's also the story of my journey, really, from being a neurotic postnatal mother to being a home energy advisor, an MSc student, and a woman with an extensive commitment to plastering. So it's a story about the practical and analytical skills our family have built, really, in renovating our house. So this journey took our home from an EPC of a D in 2012 to an EPC of a high B in 2020, which surpassed what was perceived as possible back then in 2012. And it demonstrates a really changing perspective of what the potential is for the energy efficiency of older buildings, I think. Much of this change was using natural and recycled materials. Particularly, we used geoglass in some of the floors with a lime screed, and we used a lime, perlite and hemp insulating plasters on a lot of the external walls. But we didn't start off this journey with architect's plans and a clear picture of the project ahead at all. In fact, we naively saw engaging a local builder who I think you can see there in the top left with his dog. So we engaged Rory to make some quick fixes to the house before we got on with a permaculture project that we'd moved here to engage in. But as the roof caved in and skips and concrete began to arrive, we began to realise that the impacts of what we were doing and that the permaculture project, it had to start here and now, really, with the building. It wasn't something to start in the garden afterwards. So the scale of the work was bigger than we'd ever imagined. This was an evolving and stressful journey in which we felt we were losing the culture of our house to start with. The big old trusses, they were all rotten on the ends and they were getting wrenched out, and we were sitting in a static caravan in the rain watching this happen, and we were really feeling that we were starting to lose control. And we didn't feel it was right. And we felt our responsibility to the building and to the world in terms of the impact of the materials that were getting bought on our behalf. Everything felt really rushed, and we felt we had to make complex decisions under pressure. And so we made the decision we made an agreement with the builders working on it to get to a point where the building was stable. So we got a roof on and we got some windows in, and then we stopped and we came up for air and took a breath for a while. When you buy a house, people often say that you should live with the garden for a year before you do anything. see what comes up, see how you use the space, and see where you like to sit in the evening, where the sun shines down in the evening. Whereas with a house, we often get work done before we even move in, and before we understand the ground that it's standing on, the things that it's made of, or the place that it holds within the local community. So we really realised that there was a benefit to learning ourselves and for ourselves by being involved in the doing. So during this time, we engaged in a social experience, really, of understanding material, of a deep connection to the space where we lived and what it's made of. We talked to and got to know local people doing similar projects, and we started to learn from them about where to get materials and how to process them. We engaged in soil testing, digging holes, fermenting dung in a wheelbarrow. We dried and crushed and sieved clay. We slaked lime, and we mixed all these things together in different proportions to make plasters and screeds. And through this process, we started to gain a deep personal understanding about our house and our locality. We started to understand, really understand, the place that we lived. And from this understanding of our own building, the materials we were using and how they worked, we started to become empowered. We were able to gain in skills and in confidence outside of the gaze of conventional builders. The project has demonstrated to me the importance of women developing a new tactile relationship with their buildings, their homes, one concerned with health, beauty and functionality, and one that's unconstrained by a male-led construction industry focused on cost and efficiency. And it was to us accessible with a minimal cost of tools and equipment and a propensity to a creative approach. So by this stage in the project, we're probably a couple of years in by now, we developed a set of questions really to help us to make decisions. But as you gain knowledge, you start to realise just how little knowledge you've got. So we were asking ourselves, how can we tell if cork or perlite insulation is the best? What should we do if we've got a limited amount of headspace? Would it be better to use king span and get loads of it in? Or would it be better to use sheep's wool but have less of it and have more heat escaping? And we realised we didn't know the answers and we didn't know how to find them out. And this represented for us really a significant turning point in our journey. I developed a real interest in some skills in plastering, and I was looking for a way to develop this as a career. And as a family, we were becoming daily aware of our lack of knowledge to make informed decisions. Relying on manufacturer claims, urban myths, and YouTube felt really precarious. And so I decided to embark on an MSc with the Centre for Alternative Technology in Green Building. The course started to put a context and deeper understanding behind some of our own points that we'd started to develop for ourselves. And it made me think more deeply about the power of the money we were spending. If we spent our money locally, worked to build local skills, even if it cost more pounds, we'd be buying something more, something that would build our community, and in turn that would then benefit us back. It helped us to understand that a sensitivity to maintaining the building's features wasn't simply a middle-class aesthetic, which is something I'd been beating myself up about a bit, but it was in fact a preservation of cultural heritage. It was playing a role in our whole community's understanding of our place in history. It introduced to me ideas that materials themselves have vitality and agency, that we don't live independently of materials. We are in fact a product of the earth ourselves, and the relationship of impact between people and materials is not one way. So this section of my talk, I'm going to just focus a little bit more on a plaster binders analysis that I did as part of my MSc. The study compared clay, lime, dung and gypsum, and I started to pick apart really how these binders were made, how their bonds worked, and what the carbon implications were. Now, I kind of, this whole section of my talk, I'm aware that there's probably many people here that know much more about this than me, and do bring things to me if I make mistakes in the questions afterwards. But I'm kind of talking about this analysis really because of the importance it played for me in my journey, and being empowered to be able to sort of look at and decode some of this information for myself. So I started to explore how to compare data and the importance of comparing like for like. And I'll just draw out of this slide here the data here on lime. I don't know if you can see my pointy cursor. I hope you can. But when I looked at the ICE data on lime plaster, it came in at 0.78. And when I looked in Burge's book, it came in at 0.19. I was like, that's quite an anomaly, isn't it? But when I looked with a little bit more detail, I could see that ICE is just looking at the pure lime, whereas Burge is looking at a complete lime plaster. So if we say making our mix at a 1 to 3, that starts to be quite comparable. We can see how those numbers work together. But Burge is also telling us that there's a potential recarbonisation of 0.12, bringing his figure down to 0.7. So if we were to misread these figures, we could be tenfold out. So that example for me just really helped me to, when you're looking on a manufacturer's claims, it's really hard to compare information if you don't come back to exactly what it's talking about and how the materials work and the implications of those numbers. So yeah, it showed me the importance of moving away from publicity material and manufacturers' claims, so that I'm using reliable, comparable data, and the importance of being able to understand that for myself. So I found that none of the binders were particularly bad, not if you compared them to steel or glass that might come in at around 6 kilos of CO2 per kilo. That can't be right. I don't know how I've written that. But we use them in such quantity that it does start to make a significant difference. If you think about how much glass you've got in your house compared to how much plaster, even though plaster's CO2 isn't that high, the sheer quantity we use it in means that reductions in that can have a bigger impact. I also looked at how the materials would behave in a building that was built to breathe. So I found that gypsum was the worst performing against clay and lime in terms of its vapor permeability, its breathability. And I looked at the implications of associated insulation type. I found that the binders clay and lime were associated with insulation types such as hemp, straw and cork, whereas drywall systems are associated with PIR, EPS, XPS, and that consistently these Kingspan type insulations were full of chemicals that were harmful to people, whereas the chemicals associated with the lime and clay were having positive impacts, antifungal, antidepressive qualities. So it really sort of demonstrated that plaster choice can impact insulation choice, and that has a significant knock-on effect socially and environmentally, especially given that these commonly used rigid insulations have got a very high CO2e as well. So coming back to Cumbria Hill House, and we were starting to understand that lime isn't good just because it's lime, that centralised production, social and transport implications and regulatory requirements all impact how good or appropriate a material is in a given situation. That reasons for choosing materials are complex. Bagged lime is specifiable. It's expensive, but it's easy to use. Gypsum's cheap and even easier to use. And self-slaking costs time instead of money, but needs space and is unregulated. So we asked ourselves, how do we know about materials? No one's going to endorse non-monetary value materials. No one's going to raise our awareness of the soil in our own garden by trying to sell it to us. It became apparent to us that there wasn't one correct answer. Each building would have its own cultural, social, practical and financial constraints. So how did all this fit with our specific project. So you can see on this slide here, we drew a 40-kilometre radius around our house and looked at the available materials. And then we really challenged ourselves and drew a 200-metre radius to see what was available in the immediate vicinity. And though there was lime available in the area, it wasn't accessible. So there was a quarry there, but you couldn't buy it as slaked lime. The nearest place we had for buying quicklime was somewhere down here, probably about 50 miles away, something like that. So our house was originally built with lime, and it had a need to breathe. It needed a vapor open material. And we looked at what we'd used so far, and really we'd started off using an NHL bagged lime because it had been sold to us by a Cumbrian company. And so in some respects, we felt like we were doing a good thing because we were using a material from a local company. But when we started to look more closely, it was an insulating lime. The hemp was coming from France. We didn't know where the perlite we were putting it in was coming from. And we were being sold a bagged NHL lime. We'd moved away from that to slaking our own lime, but we still didn't know where all these added ingredients were coming from. And so we found this a really interesting process to realise that actually in our garden was a plaster binder we could use. We didn't need to be driving 50 miles slaking lime. We had piles of clay just outside. So we undertook an experiment to top coat plaster 2 bedrooms with a clay dung lime mix, using clay and dung from within 200 metres and Cumbrian lime that we slaked on site, as it helped adhesion to the insulative lime backing. So it was small scale, labour intensive, done by hand, but done by us. And here's the results. So the plaster was workable. It adhered to the lime and dried well without much cracking. There was some mould that occurred in the corners when it was drying slowly, but we think that was because we put too much dung in the mix. It allowed a sensitivity to the undulating qualities of the walls. And the result's not the original material, but it does feel sensitive to the building. It was able to be made and applied by us, the homeowners, with the only monetary cost being the lime, which was slaked on site. There's no requirement for decorating. The farm across the road has a thriving pea patch as we swapped seedlings for dung. We found a home for the clay we dug out of our house, and we dug out to house the trampoline in the garden. And as a family, we have a deeper connection with where we live through our plaster choice. So I've brought my family in just for 1 minute at the end because it's been very much a family project. So this is Eartha, who's 7. So Eartha, what's it like having a cow-dung plaster bedroom? This is Eartha's bedroom, by the way, in the background. What's it like, Eartha?
I use it as a desert. I am going to make some lizards and camels.
Fantastic. And this is Ada, who's 14, who she's done a lot of plastering and digging and sieving clay.
So I have my plaster wall has a window in the middle of it, and I think it's really nice that it integrates the outside. It brings it into my room. So I'll be looking out my window in the morning, and I can see the outside is actually in my room, which it kind of has a sense of pride with it because I dug up quite a lot of that clay. I smashed quite a lot of that clay in buckets, and just see that my mum plastered that onto the wall and seeing that in your bedroom, it's quite a sense of accomplishment.
Great. Well, thank you very much for listening. I hope that's been helpful. I've made a slide of references if anybody wants to follow them up as well. Thank you.